Hello, precious students. I welcome you once again to our SHS 3 Core Mathematics program, brought to you by the Center for National Distance Learning and Open Schooling. My name is Ben. We are going to continue with our discussion on the topic Mensuration II. In our previous lesson, we discussed volume of a pyramid. Today we shall look at the surface area of a sphere. By the end of this lesson, you will be able to 1. State the properties of a sphere, calculate the surface area of a sphere, and calculate the surface area of a hemisphere. A sphere is a solid bounded by closed surface which is equidistant from a fixed point called the center. An example of a sphere is an egg, an orange, a basketball, or the globe. You see a picture of a sphere on the screen. A sphere is also defined as the set of all points in three-dimensional shape that are located at a distance r, that's the radius, from a given point, which is the center. The surface area of a sphere is given by the formula 4 pi r squared. Let us look at some properties of a sphere. 1. Every section in the sphere made by a cutting plane is a circle. Now, if the cutting plane passes through the center of the sphere, the section made is a great circle. Otherwise, the section is a small circle. And you see a diagram of a great circle and a small circle. For a particular circle of a sphere, the axis is the diameter of the sphere, perpendicular to the plane of the circle. The ends of the axis of the circle of a sphere are called the poles. The nearer the circle to the center of the sphere, the greater is its area. Another property is the largest circle in the sphere is the great circle. The radius or diameter of the great circle is the radius or diameter of the sphere. All great circles of a sphere are equal. Now, every great circle divides the sphere into two equal parts called the hemisphere. We shall now look at some worked examples. Example 1. Calculate, correct to 2 decimal places, the surface area of a sphere with diameter 10 centimeters. Again, we are going to take our pi to be 22/7. Now let's look at the solution. We have been given the diameter to be 10 centimeters, and that means the radius is 5 centimeters. That's if you divide the diameter by 2, you get the radius to be 5 centimeters. Our pi is given as 22 divided by 7. Then we quote the formula for finding the surface area of a sphere, which is 4 pi r squared, and we substitute our values. So we get A equals 4 multiplied by 22/7 multiplied by 5 squared. If you simplify, we get 314.2857. We are to correct our answer to 2 decimal places. So that will give us area equals 314.29 centimeters squared. Therefore, we say the surface area of the sphere is approximately 314.29 centimeters squared. We take another example. A sphere has a radius of 9 centimeters. Calculate, correct to 1 decimal place, the surface area. Here, we assume pi to be 3.142. Let's look at the solution. Surface area of a sphere is 4 pi r squared. You have been given our pi to be 3.142 and the radius is 9. So if you substitute, we have 4 multiplied by 3.142 multiplied by 9 squared. When we simplify that, you get 1018.008 centimeters squared. We have to write our answer to 1 decimal place. So that gives us 1018.0 centimeters squared. Let's now look at the hemisphere. A hemisphere is the half part of a sphere. We can find many real-life examples of a hemisphere. If you have a coconut shell divided into 2 parts, an orange divided into 2 equal parts will show an example of a hemisphere. The human brain is divided into 2 hemispheres, known as the left brain and the right brain. Another example is the earth is a sphere that is divided into southern and northern hemispheres. A hemisphere can either be closed or open. For example, half of an orange is a closed hemisphere, and half of a coconut shell is an open hemisphere. Let's now look at the surface area of a hemisphere. We shall look at the curved surface area. The area of the outer portion is called the curved surface area. To find the curved surface area of a hemisphere, we divide the surface area of a sphere by 2, because the hemisphere is half of a sphere. So we have half multiplied by the surface area of a sphere, and that gives us half multiplied by 4 pi r squared, which gives us 2 pi r squared. Let's take an example. Find the curved surface area of a hemisphere with radius 2 centimeters. Let's take pi to be 3.14. Now the solution. The formula for finding the curved surface area of a hemisphere is 2 pi r squared. So if you do a substitution, then we have 2 multiplied by 3.14 multiplied by 2 squared. And that will give us 6.28 multiplied by 4, which is 25.12 centimeters. Let's take another example. Find the curved surface area of a hemisphere having the radius of 7 centimeters. Let's look at the solution. The given values, that's the radius, is equal to 7 centimeters. Our formula is 2 pi r squared. So we substitute the values into the formula, and we have 2 multiplied by pi multiplied by 7 squared. We know the value of pi. So if you do the substitution, then you have the surface area to be 308 centimeters squared. We are now in the position of calculating the total surface area of a hemispherical object. We may have 2 conditions. 1, if you have a hemispherical object, then it has a base which is a circle of radius r, as you can see on the screen. The area of a circle of radius r is pi r squared. So to find the total surface area of a hemisphere which is closed, we add the base area to the curved surface area, which gives 2 pi r squared plus pi r squared, and that is 3 pi r squared. The 2 pi r squared is the curved surface area, and the pi r squared is the base. Let's take an example. Find the total surface area of a hemisphere with radius 2 centimeters. Take pi to be 3.14. Let's look at the solution. We know the formula for finding total surface area of a hemisphere. That is 3 pi r squared. So if you do our substitution, then we have 3 multiplied by 3.14 multiplied by 2 squared, which will simplify to 9.42 multiplied by 4, and that will give us 37.68 centimeters. That was very easy. We have learned that a sphere is a solid bounded by a closed surface which is equidistant from a fixed point called the center. We can find the surface area of a sphere of given radius using the formula A equals 4 pi r squared. We have also learned that a hemisphere is the half part of a sphere, and it can either be closed or opened. The area of a curved surface of a hemisphere is 2 pi r squared. The total surface area of a hemisphere is equal to the curved surface area plus the circular base. That is 2 pi r squared plus pi r squared, and that gives us 3 pi r squared. Well. I hope you have enjoyed the lesson and will make a date with us in our next lesson on the volume of a sphere. Until then, it's goodbye.